Good morning, everyone. My name is Vicente Sanz Marco, and I will present this research project that it was a collaboration between Spanish Oceanographic Institute, the University of León, and ICE. Uh, we made this project because in Spain was a powerful production of sea bass and sea bream. However, when the crisis came, Greece and Italy dropped drastically the sea bass and sea bream prices, so Spain could not compete against that prices. So the government decides that the best solution is to produce a different kind of fishes or animals. In this case, they decide the shellfish, crustaceans, and Senegalese sole. For the objectives of this project, we focus in Senegalese sole, but they have a biological problem for the fish farms. First of all, the fish farmers go outside to the wild and capture some Senegalese soles and bring them to the facility, feeding them and let them to reproduce generation after generation. So that's the idea. However, the wild animals they capture, they can feed them and they can reproduce without any problem. This kind of generation, the one that they captures, is called F0 generation. And the offsprings of this generation is called F1 generation. The problem comes with the males of the F1 generation because they lose the ability of reproduction. Because they made further studies about this, they discover that the fishes get stress. Why they get stress? Because the fish farmers need to measure the fishes twice a month in order to control the food that they receive. So these fishes, because of that process, they get stress. And this not only the because the fish gets out of the tank measure because it's getting manually and then put again in the tank, they get stressed for different other reasons, such as too many food, there is not enough food in the tank, there is too many fishes in the tank, and as I said, touching and manipulating to measure them. This is an example how the fish are measured. So, to resolve this problem, we decide to create a prototype that the user takes a picture of a top view picture of the fish tank with any kind of device, it can be a mobile or a tablet, and send it to the server. The server uses deep learning models to recognize the fishes, and then after that it calculates the size of the fishes and the biomass and how much food each of these fish inside the tank needs. Then it sends information to the user. The user can use that information to put the correct amount of food and additionally see if there are too many fishes inside the fish tanks to avoid the stressful overbooking. For this purpose, we have created 4 different kinds of datasets. Just to remark, this is a picture of a fish tank, a top view fish tank. As you can see, there are a lot of fishes and they are overlapping, so it's not an easy task to recognize and measure them with an image. So 4 different datasets has been created. The first dataset, called with reference object, contains 2,000 images of Senegalese sole and 200 images of golf balls. That the golf balls, as you can see in the next slides, will be used as a reference object to measure the fishes. Second dataset, it's a total of 2,000 images, but without any golf balls images. So this dataset contains the real world measures of every fish in those images. and is called without reference object. The third dataset it contains images of the Senegalese soul eyes, around 1,500 images. The fourth one is similar to the previous one, but only containing tails of the Senegalese soul. These datasets are used for training the neural networks that will be used for this project. Additionally, we have used a semantic regeneration network that is a very interesting neural network an application that help us to regenerate the missing parts of the face individuals. So the idea is we send this original input because just remind that there is overlapping among them. So because it's not possible to see the whole face, we need the size of the whole face, we just use semantic regeneration network to regenerate the missing part that could not be captured by the picture. So as you can see, the reconstruction is very similar to the ground truth. For this purpose, we have used the 2000 Senegalese face images from without reference object dataset. For this purpose, we have created 4 different algorithms. The first one is the detection model with a reference object. The second one is using the first algorithm, but adding the eyes detection. The third one is using the second algorithm and adding the tail detection. And the fourth one is a detection model without reference object. The fourth algorithm uses the semantic regeneration network for regenerating the missing parts of the faces. Starting with the first algorithm, the user needs to send an image of the top view picture of the fish tank and the size of the reference object. For this purpose, we use a golf ball, but in case you wanted to use a different reference object, you will need to retrain the algorithm. As the fish are detect the detection model, detect the fish, and use the SRN to regenerate the fishes. After that, the fish are detected, an application calculates the size of each fish using the size of the reference object. For this purpose, for this detection, the fish detection, we have used inception versus form. For the second algorithm, the first steps are similar. The user needs to send an image and the size of the reference object. So we use the SRN to regenerate the missing parts of the faces and the fish detection to detect them. Then, instead of use the reference object directly, we just detect the eyes fish using inception versus 2 that it has been trained for this, and then we use the eyes to get the orientation of the fish. Using the orientation of the fish, we can determine better the size of the fish. We are using length and width to determine the biomass. So as you can see, the length here was 32 and here is 31, so it's 1 centimeter of difference. If we go to the third algorithm, the first steps are similar. The user needs to send an image with the size of the reference object. We use the SRN and the fish detection, but instead of detecting only the eyes, we are detecting as well the tail. So we are using the eyes of the tail to get the orientation of the fish. As you can see, here is saying the fish is in 116 degrees and here is in 112 degrees. And the lens has a different detection, as well as the biomass. But how is this fish orientation calculated. So we have created a new algorithm that first the physics are detected as well with the reference object, but we only focus on the physics for the orientation. Then every phase is kept in frames. After every phase is kept in frames, we detect the eyes and tails, and we create a line from the middle of the eyes frame to the middle of the eyes of the tail frame. After that, we generate diagonals and horizontals and verticals of the frame, and we use these diagonals with all these lines to calculate the orientation of the face. The error percentage of this face orientation calculation is lower than 1%. However, if only eyes or tail are detected, the detected one is used to determine the orientation, so it will work as algorithm 2. Nevertheless, if not eyes or tail are detected, algorithm 1 is used. So each phase has it use one algorithm or another one. Okay. So algorithm 4 is an idea that we think it could be different and maybe it works better. So we go ahead and implement it. So the idea is very simple, but it could be very powerful. So we generate a new neural network, in this case 13 layers, using convolutional, ReLU, max pooling, and fully connected layers. We didn't want to use any kind of reference object, and we want to improve the execution time. So the idea is the user sends an image, only the image, and the neural network generated here, the 13 layers, just detect the faces and calculate the length, the width, and the biomass of the faces. For this training this new neural network, we have used the dataset without reference object. We have decided to use the 13 layers because we have tested with different amount of layers, and this one is the one that gives us the best results. If we compare the accuracy of the face detection models, because we need to decide which detection model to use in algorithm 1 and 2 and 3 and 4. So we decide to make a comparison, and as you can see, we decided to use Inception versus 4 because it has the highest accuracy on face detection. And the time is better than other ones, like the Inception Resonate versus 2 has highest time than Inception versus 4. Regarding the eyes detection and tail detection, we use Inception versus 2 because it has better time than Inception versus 3 and 4, but the accuracy is not that much different. It's 1% different. It's true that we can use Inception Resonate versus 2, but the time of the tail detection was 3 times more than Inception versus 2. So we are playing with the variables of accuracy and time. If we make a comparison of these 4 algorithms, this one is the algorithm 1, algorithm 2, algorithm 3, and algorithm 4, we can see that if we compare them using the average error measuring, the algorithm 4, that is only using the neural network, it gets an error of 3 centimeters. So every time that it's measuring or detecting a face, it gets an error of 3 centimeters. So that means maybe he thinks the face is 3 centimeters larger than it's in the real world. The best one is algorithm 3 that has only 0.5 average error. After talking with our partners in the oceanographic, they said 0.5 is a really good result because it can happen in the real world when you are measuring because the fish is moving a little bit, so it can happen. So 0.5 is a really good error measuring. After that, we compare them with the error biomass calculation. Again, the eyes and tail detection algorithm, together with the neural network, algorithm 3, it obtains the best results with the minimum error and with the minimum max error. It's true that the eyes detection only, it just get close, so that's, and the neural network with the reference object is kind of far. And the worst is the algorithm 4. However, if we compare them with the execution time, that is getting how fast the user gets the response after sending the image, and well, how fast all the algorithm finishes, all the pieces are detected. Algorithm 4 is the fastest one, just less than 0.7 seconds. And algorithm 3, that it has the best in error measuring and biomass calculation, is the slowest, getting almost 2 seconds to calculate the phase information. To conclude, we have created a fast and accurate algorithm to measure Senegalese salt pieces in a fish tank. It's a very difficult task, and there are nothing like in the market like this because of the overlapping behavior. Because all of the fishes are in the lowest part of the fish tank, and they all like to overlap each other. These algorithms created, this application, can calculate the biomass and the necessary food for the fishes. So it only uses a top view photography, can be taken by any device like mobile or tablet, and it's not necessary any kind of installation in the tank, and it's easy to integrate in a fish farm system. For this purpose, we have created 4 different algorithms. That is with the reference object, with the reference object eyes detection, with the eye tail detection, and with alternate reference object or any kind of eyes tail detection. If the user wants the more balanced way, the time and accuracy, algorithm 1 and 2 are the best options for him. If he wants the best in execution time, algorithm 4 is the best one. If they want the lowest estimation error, algorithm 3 is the best one. We have achieved a reduction in the human and animal interaction, making it necessary to get the fishes outside the tank, and they will not get any stress in any kind, because we can calculate the biomass enough to avoid that. Additionally, and to conclude this presentation, this system can be extrapolated to other fish species, and it can be extrapolated to other captivity conditions like a zoo, and it's possible to calculate that it can be possible to calculate lion size and how much food it needs. For this purpose, it will need to retrain the models, but the algorithm will be the same. Thank you very much.